Your quadriceps don't stretch significantly after a 30-second hold. Contrary to popular belief, muscle fibers elongate only temporarily. Research from the University of Nevada shows no lasting increase in muscle length. This is because the muscle spindle, a sensory organ, quickly returns muscles to their original state. Instead, stretching increases tolerance to discomfort, not flexibility. Your nervous system adapts, reducing signals of pain. The real change occurs in your central nervous system, not the muscle itself. So while you feel looser, the actual muscle structure remains unaltered, influencing how you approach flexibility training. Muscle extensibility is more about neural adaptation. Sit-ups don't torch belly fat specifically. When you perform 100 sit-ups, you're engaging your rectus abdominis, but not targeting fat loss. Fat reduction is systemic, not localized. A 2011 study found abdominal exercises alone didn't significantly affect abdominal fat. Instead, calorie expenditure through full-body exercises influences fat loss. Your liver, a prime player in energy balance, metabolizes fat as a whole-body process. So crunches won't carve abs until overall energy balance shifts. Your metabolism prioritizes fat breakdown based on genetics and hormonal signals, not exercise location. Spot reduction remains a persistent fitness myth. Weightlifting doesn't stunt growth in teens. Growth plates, or epiphyseal plates, are the cartilage areas near the ends of long bones. These plates are sensitive, but moderate resistance training is safe. A review in the Journal of Pediatrics indicates no negative effect from controlled strength training. Proper supervision and technique are crucial. Bones adapt to the forces placed upon them, meaning they become stronger. This adaptation involves osteoblast activity, which supports growth, not inhibition. The myth likely arose from improper techniques causing injury, not the exercise itself. Safety and form trump the myth of growth hindrance. Cardio isn't the ultimate calorie burner. High-intensity interval training, HIIT, can eclipse steady-state cardio in calorie burn. A 2015 study in the Journal of Sports Sciences found HIIT sessions led to greater post-exercise oxygen consumption. This means your body continues to burn calories even after the workout ends. The mechanism involves increased mitochondrial efficiency and glycogen resynthesis. Your metabolism stays elevated longer, a phenomenon known as the afterburn effect. Traditional cardio mainly burns calories during the activity itself. HIIT's impact extends beyond the gym, influencing metabolic rate. Your body's metabolic response to exercise is more dynamic than static calorie burn. Running isn't inherently bad for your knees. Knee osteoarthritis is often attributed to running, yet evidence suggests otherwise. A 2017 study in the Journal of Orthopedic and Sports Physical Therapy found no correlation between running and increased knee arthritis. Moderate running enhances cartilage strength through increased nutrient flow. Synovial fluid, which nourishes cartilage, circulates more efficiently during running. Joint health is also influenced by muscle strength and stability. The myth stems from improper form or overuse, not the activity itself. Supporting muscles and tendons, when conditioned, protect the joint structure. Your knees adapt positively to consistent, moderate stress. When performing squats, your neuromuscular system synchronizes muscle fibers. Motor units, groups of muscle fibers and their innervating neuron, fire together. This recruitment maximizes force production. The squat engages large muscle groups like quadriceps, gluteus maximus, and hamstrings. Each motor unit adapts by increasing firing frequency and synchronization. With consistent practice, motor unit recruitment becomes more efficient. This efficiency contributes to strength gains, not just muscle growth. Your central nervous system learns to optimize movement patterns, enhancing coordination. Squats fundamentally alter your neuromuscular pathways, shaping how your body responds to load. Deadlifts stimulate a hormonal cascade, particularly cortisol and testosterone. A 2012 study at the University of Connecticut found compound lifts trigger testosterone spikes. This spike peaks at 15-30 minutes post-exercise, returning to baseline within 60 minutes. Cortisol, a stress hormone, also increases but within a manageable range. These hormones regulate protein synthesis and muscle repair. Testosterone drives anabolism, promoting muscle tissue growth and repair. Meanwhile, cortisol aids in metabolic regulation, ensuring energy availability. The balance between these hormones is crucial for recovery and adaptation. Deadlifts engage this hormonal interplay, crucial for muscle adaptation. During push-ups, connective tissue remodeling occurs in tendons and fascia. Collagen fibers align along the lines of stress, increasing tensile strength. A 2017 study in the Journal of Applied Physiology highlighted tendon adaptation. This adaptation involves fibroblast activity, which synthesizes new collagen. As fibers thicken, tendons become more resilient to strain. Fascia, the connective tissue surrounding muscles, also adapts by becoming more pliable. This pliability enhances force transmission across muscles. Your body's connective network responds dynamically to mechanical stress. Push-ups thus fortify not just muscles, but the structural tissues supporting them. Pull-ups initiate mitochondrial biogenesis in muscle cells. Mitochondria, the powerhouses of cells, increase in number and efficiency. A 2014 study in Cell Metabolism detailed this aerobic adaptation. Enhanced mitochondrial density improves energy production through oxidative phosphorylation. This process fuels prolonged muscle contractions without fatigue. The cellular signal, AMPK, activates pathways promoting mitochondrial growth. With regular training, your muscle endurance increases due to these cellular changes. Pull-ups don't just test upper body strength, they transform cellular energy systems. Your muscles adapt to sustain higher workloads with greater efficiency. Lunges activate proprioceptive feedback mechanisms, enhancing balance and coordination. Proprioceptors within your muscles and joints send signals to your brain about body position. These signals facilitate balance by adjusting muscle tension and joint angle. This neuromuscular feedback loop refines your movement efficiency. The vestibular system in your inner ear plays a role by providing spatial orientation. As you lunge, your brain integrates this sensory input to maintain stability. Over time, this improves kinesthetic awareness and coordination. Lunges not only strengthen muscles, but also fine-tune the intricate communication between your body and brain. Overtraining without adequate recovery leads to chronic inflammation. Your body's inflammatory response, initially protective, becomes detrimental with persistent stress. Cytokines, proteins involved in cell signaling, remain elevated in an overtrained state. This prolonged inflammation interferes with muscle repair and adaptation. A 2010 study in Medicine and Science in Sports and Exercise found consistently high training loads impair immune function. The imbalance between training intensity and recovery disrupts hormonal balance, particularly cortisol. Elevated cortisol can inhibit protein synthesis, crucial for muscle recovery. Therefore, understanding the inflammatory and hormonal balance is key to preventing overtraining. Inactivity, on the other hand, triggers muscle atrophy and metabolic decline. Within just 2 weeks of inactivity, muscle mass can decrease significantly. A 2015 study in the Journal of Rehabilitation Research and Development found muscle protein synthesis rates drop sharply. This leads to rapid loss of muscle fibers. Disuse also affects insulin sensitivity, increasing the risk of metabolic syndrome. Your muscles become less efficient at utilizing glucose, affecting energy regulation. The mitochondria within muscle cells reduce in size and number, decreasing aerobic capacity. Without regular stimulus, the body's metabolic efficiency dramatically declines. The fitness industry often promotes the latest trends over proven methods. Yet, a 2018 meta-analysis in sports medicine showed compound exercises offer superior benefits. These multi-joint movements engage more muscle mass, enhancing strength and metabolic rate. Fad workouts might promise quick fixes, but lack long-term efficacy. Compound lifts like squats, deadlifts, and lunges stimulate greater hormonal responses. They also improve functional movement patterns that translate to daily activities. The consistency in these exercises builds foundational strength and endurance. Despite marketing claims, fundamental exercises remain the cornerstone of effective fitness routines. Chronic high-intensity training without variation can lead to adaptive resistance. Your body becomes efficient, requiring increased intensity or volume for the same effect. A 2016 study in the Journal of Physiology noted diminishing returns with constant high intensity. Muscle fibers adapt, reducing the stimulus for further growth. Periodization, or varying intensity and volume, prevents this plateau. It allows recovery while still challenging the neuromuscular system. By cycling through different training phases, you stimulate continuous adaptation. Understanding adaptive resistance helps in designing effective long-term training strategies. Surprisingly, moderate exercise is linked to longevity benefits. A landmark 2019 study in JAMA Network Open involved 315,059 adults over 23 years. It found regular moderate activity reduced mortality risk by 31%. This involves a balanced mix of aerobic and resistance exercises. The key lies in sustained, moderate intensity rather than short-term extremes. Such exercises enhance cardiovascular health, muscle mass, and metabolic function. They also improve insulin sensitivity and reduce systemic inflammation. These physiological changes contribute to a reduced risk of chronic diseases. The study highlights the profound impact of consistent, moderate exercise on lifespan.